Electric fields. The section is combined with the previous video, and in many past papers you may see the questions are also combined or lead on from one another. They may ask you to draw electric fields, and this is what you have to look at. If it's a positive point charge, the arrows go outwards. If it's negative, it goes inwards. If there's a positive and negative, it goes from the positive to the negative. And if it's a positive and positive, meaning like charges, they repel each other and it'll go outwards. If it's negative, it'll go inwards. But these lines never touch each other. Some of the properties of electric field lines is that they never touch, they never cross each other, and it surrounds charged objects in 3D. There are two main formulas that we may look at, which is the electric field one. This is the force in newtons, this is the charge in coulombs, and this is the electric field. This is when there's a point charge. And this is your E net. Now this represents your E net of one only. You have to keep adding. So if there's 2 point charges, you add the same formula, and if there's 3, you have 3 of this. Let's have a look at past papers. X is a point 0,2 meters from point charge Q1, carrying the charge of -3 times 10 to the 5. Define electric field at a point in watts. This is not something I can help you with. You just need to by heart this or learn it from the guidelines. Draw the electric field pattern due to the charge Q1. Q1, they tell you it is negative. Negative always takes, so the arrows point inwards towards the negative. Now another point charge, Q2, carrying a charge of positive 12 times 10 to the -5, is placed at a distance of 0,35 from Q1 as shown below. What I like to do is see 0,35 minus 0,2 and put it there, just so you know for yourself that it's done and you do have that, because sometimes during pressure and during exam conditions, you can forget small things like this. Calculate the net electric field at point X due to the two charges. You have your E for each one. You can do it together, like in this case, and put this formula here and put that formula here, and then do everything in one step here, or you can do it individually like this and then just add the 2 at the bottom. So you substitute everything in. Everything, see the 0,15 came from here, what you calculated here, and you just add the 2. State Coulomb's law in words. This is something that you have to by heart from the guidelines. Calculate the magnitude of the electric force exerted by charge Q2 on charge Q1. This is your normal force equation, which we have done in the previous video. So if you haven't looked at that, look at that. Charge Q2 is moved further west. How will this charge affect the net electrostatic force at this new distance? Choose from increase, decrease, or remains the same. So west is this way. It would increase the electrostatic force because it is getting closer. Two identical metaspheres, P and Q, are suspended from a wooden bar by a light and extendable string, as shown in the diagram below. The distance between the centers of the spheres is d. The charge on the spheres are -4 and +8. Sphere Q experiences an electrostatic force. In which direction will sphere Q move? Choose from to the left or to the right. This is sphere Q, and this is positive and negative. Opposite forces attract each other, so Q will move towards P, which is to the left. The spheres are now brought into contact with each other and then separated by a distance d meters. The spheres exert a force of 0,8 newtons on each other. Calculate the net charge on each sphere. So you know that the first one is -4 and the second one is +8. You take -4 plus +8 divided by 2, which will give you 2. Now we need to convert to coulombs. So you will say times 10 to the -6. Draw the electric field pattern due to the two spheres. They both have the same charge now, thus their electric field lines will not touch, like shown here. Calculate the number of electrons transferred during the contact. So we do know that this is the formula that we have to use. We have to use Q final minus Q initial. So Q final is what you have here, and Q initial is what you have originally. Whatever that answer is, sub it into the coulombs, and this is in your data sheet. It is a constant for electrons, and you will get that to be your answer. Calculate the distance d between the two spheres. Now, this obviously has to be a force equation. We are dealing with that section. So you have everything, you're just solving for d. 0,8 they have given to you here, and you're just subbing in and solving for your unknown. This will be our last past paper. Charges 4 and -3 are placed at a distance 0,2 meters apart on a straight line, as shown below. Point P is located 0,1 meters to the right of the -3. So we have a diagram here to show you. It's here. Define electric field at a point. This you have to learn from your guidelines. Calculate the net electric field at point P, which is here. You need to do each one individually. So you'll say this is your formula, this is for the first one, and this is for the second one. This is for the +4 and this is for the -3. You substitute everything into the equation and then you add these, and this will give you your net electric field, which is here. Don't forget to add direction. A sphere carrying a charge of +6 is now placed at point P. So +6 is placed here. It experiences an initial acceleration of the magnitude 5 times 10 to the 2. Calculate the mass of the sphere. So this is a very unusual question, but it could come out. So you have to use your F net equation here because they give you the acceleration and you asked to calculate your mass. So this is your acceleration, this is your mass. Your F net is the Q and E, meaning the coulombs in the electric field, and now you put M as a subject of the equation and you basically solve for your answer. However, I did forget to tell you that you have to convert these to coulombs because it is not coulombs at the moment. So please don't forget that because you will get marked down. Hope this helps.